And here's the directory structure that you have to create to your Raspberry Pi. So wherever is your directory where you put this code, so then there has to be subdirectory static and templates. Templates contains about that HTML file, and static contains that JavaScript code for that meter. Remember to create this kind of structure, and you have to use the same names here for these subdirectory names. And now it's time for you to start to make your exercise. I think the first, and it's quite tough exercise, is to create the reference system that was explained in this presentation. Of course, the sensors you could use whatever you want by yourself, but and of course you could modify as much as you want, but your first exercise is to create this reference system that you will have some sensor data and you will have a user interface and everything's working from start to end. And you could apply the information or the knowledge that you have learned in some other sections. For example, in the I/O circuits, there is the how to connect sensors with the Arduino, and microcontrollers part there is how to use LCD display and AD converter and that LED brightness control. And microcontrollers network enabled, there is the material how to use the Ethernet in Arduino, and HTML basics, what the HTML stands for. So your first exercise is create a working system. And when you have a working system, now your second exercise is to add ambient temperature value to system and the user interface. The sensor will send this ambient temperature and the target temperature, so that ambient temperature is already ready in the sensor. If you could look the sensor's datasheet, you find out that there are also the ambient temperature available. Your duty is this to send that value till that user interface. Third exercise is to add the functionality to the other direction. So now add the second LED to your system, or you could replace the LED with the motor or some other device that you could control. That could you say that it's output device. And also to add the user interface for that, so you are able to control that LED or motor, whatever you connect there with the graphical user interface. And here are some links how to install the Mosquito server to your Raspberry Pi. These are from 2016 August, so it might be this. There are some changes, but at least at this time these links were working. And that Mosquito, after when you install the Mosquito server, it's quite easy to test that it's working. You could open the terminal window and give some simple commands to that server. For example, if you would like to start listening the out topic messages, you will write this Mosquito sub. This means there's the topic, and then there's the topic name, which topic you would like to listening. And there's supposed to be happening nothing if there is no one sending to that topic, but you could try also manually. You can open the second terminal window and then send to that channel, and the syntax is here: topic, out topic, M means the message, and send your message there. Now after this message supposed to be appear in your subscribed terminal window. So this is the easy way to check out that Mosquitto server is working. You could also give more detailed commands, for example if you want to change the port number, host name or whatever. But these are this sub and pop are these most common commands that you could verify that your server is working. And now if you will receive this message for this out topic, and when you put the Arduino to your system, it's the same way. The terminal window will show the messages that your Arduino is saying. So this is really nice also to debugging or verifying that your system is working. Doesn't matter where you send those. That's just the idea of MQTT. Doesn't matter who sends those messages. If you are subscribed to listening those messages from the certain topics, whoever sent those, you will see those. And for that Python code, for that MQTT functionality is coming with this Pauho MQTT libraries, and here are some links that you could go through and install that. And also here's that how to install that Flask server to your Raspberry. When you have installed these, then you could start to use your reference code. Here's still a small example how to use this subscribe and publish commands. I will have now here two putty screens. It's the ASCII communication program with some remote device, and in this case there is the remote connection to my Raspberry Pi. And first I will subscribe the upper window to tracking these out topic messages. Now it's activated. Now the Mosquitto server is running all the time there, and this is now it's tracking the messages which will have a topic out topic. And now if I try to send a message, let's say that my message now I was calling this publish command to that out topic, and it was sent. This was M means message, and I did send my message, and now that message appear in that subscribe part. Now, so when I send some messages here, so it appears here. And as I said, it doesn't matter if you send this from this terminal window or if your Arduino, which is connected to same network, if it's sending messages to your server, same way the messages appear here. And this is the quite nice way to track that your system, the Arduino sending system, is working before starting to create that or try that Mosquitto program. It's worth that Python program. It's worth to try this Mosquitto side that it's running and working. And as mentioned earlier, for the Arduino you have to define the Raspberry Pi's IP number, and you can get that number with this ifconfig command. And for Arduino you will need this Raspberry Pi's IP number, and that IP number you can get from Raspberry with this ifconfig. And when you press that give that command, it tells you that this Raspberry's IP number is 192.168.1.8, and this number you have to put to your Arduino, because this defines that what is the mosquito server's IP number, and they have to be in the same network that Arduino will reach this mosquito server. So this is really important to check this number and put this to your Arduino side. No other IP numbers are not needed.